Hello, everyone. Welcome. I know some of you are still getting lunch, but we'll be, I'm just going to make a couple of announcements while we're getting started. And thank you so much for coming. I'm Sarah. I'm the director of the Pop Center, in case we don't know each other. And I just wanted to say that Emily is our esteemed final presentation of the semester for the Brown Bag here today. So we're ending with a really fantastic talk, but I just wanted to give you the heads up that we'll be starting the sessions again on January 26th. So we have MLK Junior Day and some other things going on prior to that. So January 6th, we will be hearing from the remainder of our PSC postdocs, and then starting off on February 6th with Sarah Hayford from Ohio State and launching into a new semester. So we're really excited about that. I hope everybody has a restful and productive break. But today I'm here to introduce my incredible colleague, Dr. Emily Treleaven, who trained at Georgetown. I didn't know you had a BA in Spanish and psychology, but that explains the languages at the end of your CV. But then spent some time at UNC Chapel Hill in the maternal and child health program, and then did a PhD at UCSF and built a lot of the relationships I think that you're still involved in today, including the ones that you built here. Our colleague works in many different areas internationally across sub-Saharan Africa, but also in Southeast Asia and parts of Asia to really understand a little bit more about one of the topics we're going to hear about today, which is early life mortality, data quality, and how we get around the limitations of those things to improve population health among young folks through vaccines, through dealing with natural disasters and climate change and other areas. So I'm thrilled to have you today, Emily. And I also wanted to note that part of the reason Emily is speaking today is because we have funded this work through our center grant, the Population Dynamics and Health Program Center Grant, in a number of ways. And so we're trying to also allow some of our incredibly funded, amazing folks to tell us a little bit about what the center grant is supporting. So for all of those reasons, I'm grateful. And thanks everybody for coming.
All right, thank you, Sarah, and thanks to the Brown Bag Committee for inviting me. I was going to start out by thanking the PDHP and Pop Studies Endowment Funds for funding that has made this secondary analysis possible. So thank you, Sarah, and I want to start out by acknowledging my co-authors on this piece of work, Stefan Hellringer at NYU Abu Dhabi and Kasum Kayantau, who is also at the University of Bamako, who is also the co-PI of the Pro-CCM trial from which this project comes from. So I am using data from a trial in which I was a co-investigator for nearly a decade now. The trial is really large. I will talk about it more in detail in a few minutes. And it was made possible by a large amount of funders, implementing partners, and research partners across the globe. So I want to call out Muso, which is an NGO in Bamako, Mali, who implemented the community health worker intervention we evaluated and has been the leader of this body of work. So I am going to talk about some secondary analysis coming out of our trial data. I'm going to start out with some background on under 5 mortality measurement and some challenges and limitations related to collecting birth history data that's used to arrive at those under 5 mortality estimates. I will talk a bit about the trial itself, and then how we are using some trial data to look at new estimates of under 5 mortality and survey data quality. But like any good talk, I'm going to start out with some acronyms and definitions. So many of you in the room are demographers, and this you could recite in your sleep. But for those who are a little less familiar, U5MR stands for under 5 mortality rate. That is the number of deaths to children under 5 years of age per 1,000 live births. We'll also be talking about IMR, or the infant mortality rate. That is deaths in the first year. And NMR is neonatal or newborn mortality rate, which is deaths in the first 28 days per 1,000 live births. I will be talking about full birth histories, which is often abbreviated as FBH. And Pro-CCM stands for Proactive Community Case Management, which was the intervention in the Pro-CCM trial. And some good news, because we could all use good news these days. We have seen really, really significant declines in under 5 mortality in the last 25 years, thanks to really targeted investment and intervention and efforts globally. We have seen under 5 mortality decline from about 10 million deaths per year in 2000 down to about 5 million in our most recent estimates. And newborn mortality, so we have the rates and number of deaths globally to children under 5 in dark red. The yellow lines are newborn deaths. And we haven't seen as much movement in newborn mortality. A lot of the decline has come in preventable causes of death, pneumonia, diarrhea, and malaria, and getting kids treatment earlier and preventing those deaths, whereas neonatal causes of death tend to be a little harder to address. All right, so shifting to estimating under 5 mortality, how do we estimate it? The easy way is through vital records. If you have a place that has complete information on all births and deaths, that's a pretty straightforward way to estimate. That's what we typically do in places like the US, Canada, Europe, Japan. Or if you have regular and high quality censuses, you could also use census data. But in a lot of lower and middle income countries, we have very poor vital records. Birth registration is incomplete, and often there is very little or no death registration. And censuses tend to be highly irregular and maybe of variable quality. So we have to rely on population-based surveys like the demographic and health surveys. I'm going to talk a lot about the DHS or demographic and health surveys throughout my talk today. I want to acknowledge they have been defunded with the elimination of USAID, and that's a really important source of data for countries and researchers globally. So I want to acknowledge that. I have a few critiques of DHS, but they have done a lot of really wonderful work over the years, both to share data widely, provide important data to countries, and assess their own data quality, and provide lots of references and support to demographers and health researchers globally. So within population-based surveys, we can use both summary birth histories, which are just counts of the number of births and deaths a respondent has had in her lifetime, or better, full birth histories, which also collect information about the characteristics and timing of births and deaths in a respondent's lifetime. But birth history data are biased. So to get to valid, precise measures of under 5 mortality from full birth history data, that requires valid individual level reporting on birth dates and the timing of death or age at death. We see a lot of age and calendar date heaping. So a lot of children more than expected might report that they are certain ages or born in certain months. We commonly see date displacement, so reporting incorrect dates. Poor specificity, responses like, well, it might have been March, it might have been May. Non-numeric responses, it was around the time of the flood. And other forms of measurement error. There's a lot of recall bias because women are reporting on births and deaths that happened a long time ago, in some cases up more than 2 decades. And we see that errors are more common in settings that have poor vital registration and low healthcare utilization, because people are less likely to have ever received a document that has a child's date of birth on it. It's also more challenging in settings where they don't rely on Gregorian calendars as much or have low numeracy. And these are the same places that typically have the highest rates of under 5 mortality. So just to illustrate issues around date and age heaping, this is a graph from Anna Folk-Larson's paper in demography back in 2019, where she assessed something like 92 demographic and health surveys and documented lots of peaks at exact ages. So we see a lot of children that are reported as exactly 12 months, 24, 36, and 48 months. Far more than would be plausible in a population. And this becomes problematic when we're trying to distinguish between deaths that occurred in the newborn or post-newborn period, or the infant and post-infant periods. And then we also see a big drop-off here at 59 months because we have something called survey learning, where moms figure out, if I tell you my child is 4 years old, you're going to start asking me another 30 minutes of questions about that survey. So maybe I'll say that they're 5 years and a month. Or the enumerator is pushing that so that they can get out of the household sooner. So we can see this at a population level, but it's really difficult to distinguish at an individual level which observations are incorrectly reported. So how could birth history data be less biased? Well, from a systems perspective, we could improve vital registration, we could improve healthcare utilization so that more people deliver at health facilities and have records from early childhood immunization. That would lead to better documentation. But that is really, really difficult to do, and it's out of the purview of survey implementers. So surveyors can rely on recall aids, which should reduce measurement error. Incorporating recall aids in surveys is really promising because they reduce the cognitive burden for the respondent in reporting retrospective demographic events. So, for example, occurring when a child's birth occurred relative to dates of a national or local event, like elections or a natural disaster. But these are still requiring respondents to map their event to a Gregorian calendar. So it could be that integrating these types of events or non-numeric timing measures directly into response options could further reduce errors so that we're not putting the burden on respondents to decide when their event occurred. And we can handle those analytic decisions in a more systematic way. So in this analysis, we're using data from the trial in which we ended up getting full birth histories at 3 different survey waves. So it's a really unique data source for having multiple full birth histories within the same women. So the same woman is telling us about the same birth at multiple time points. To our knowledge, we haven't found other studies internationally that have done that. There are a few in the US. Most full birth history data comes from cross-sectional surveys, or in panel studies, typically respondents just provide an update rather than redoing the full birth history again. So in our study, we're going to estimate the rates of within birth inconsistencies in repeated full birth histories. And then we will examine variation in newborn, infant, and under 5 mortality under different assumptions for dates of birth and dates and ages of death. So we'll see, if we make different assumptions or use different cleaning procedures, how does that shift those mortality rate estimates, and then see how the use of non-numeric response options for birth and death timing affect mortality rate estimates. So I will pause here and talk a bit more about the overall trial. This was a trial that was done in rural Mali, about 600 kilometers from Bamako, the capital, close to the border with Burkina Faso. And the trial site was selected in partnership with the Malian Ministry of Health because it was a particularly disadvantaged area within Mali. It had a high fertility rate and high under 5 mortality rates prior to the start of our trial. We estimated a baseline under 5 mortality rate of 153 per 1,000 live births. And it's an area where there's really low educational attainment and school attendance among women, low literacy, and a really poor vital registration system. So the trial was a 3-year cluster randomized trial to test a community health worker intervention, which I'll talk more about in a moment. Our primary endpoint was under 5 mortality, so we wanted to estimate the effect of the intervention on under 5 mortality rates. And so that meant we had a really large sample size. We also had a large number of secondary endpoints: infant and newborn mortality, contraceptive use, maternal health, and child health indicators. And all households in the study area were eligible to participate. It was a pragmatic open cohort design, meaning we wanted to test it in real world conditions and people could join the trial after the intervention launched. So if you moved into the study area after the intervention launched, you were still eligible to participate. And we implemented the trial in 137 village clusters across 7 health catchment areas. So to summarize the intervention super briefly, MUSO has trained a large cadre of community health workers to offer a set of reproductive, maternal, and child health services. CHWs offered the same set of services in the intervention and control arms. The only difference was that in the intervention arm, community health workers went door to door and were supposed to visit households at least once every 2 weeks, all the households in their assigned zone. And when they weren't doing door-to-door visits, they offered those same services from a fixed point in the village. In the control arm, community health workers only offered services from the fixed point in the village. But in both arms, there was a CHW, at least in the village. Those community health workers were salaried, had a mobile application to help them organize their work, and had supervisors. MUSO did some infrastructure upgrades and reinforcement trainings at all of the primary health centers in the study area prior to the intervention. And most importantly, they eliminated all user fees. So no one paid anything for services from the community health workers or at the primary health centers. And at the time of the trial, there was virtually no private sector in this area. So it really does represent the universe of healthcare. So what happened in the trial? Well, there was no difference in under 5 mortality by trial arm, and there was no difference in facility delivery by trial arm. We did see positive significant effects of the intervention on antenatal care indicators with timing of initiation of antenatal care and number of visits over the course of pregnancy. But where we really saw results were across arms. So we saw a 60% reduction in under 5 mortality across the trial arms from baseline to the end of the trial period, and increases in facility delivery and healthcare utilization for children under 5 relative to baseline, again, across arms. So that suggests that these differences are due to the aspects of the intervention that were implemented in both arms, not due to and that there was no necessarily added benefit of having community health workers offer services at households rather than in the village. So I can talk more about that in the Q&A if people are interested. To estimate the effects of the intervention, we did a household panel survey. So all individuals in the study site were eligible, so we attempted to visit all households in the study area. At baseline, that was just under 100,000 people in just under 16,000 households. We estimated a 98% response rate, which is typical in settings like rural Mali. And after the baseline survey, we launched the intervention and then did 3 follow-up waves approximately every 12 months thereafter, ending in April of 2020, luckily 2 days before the first positive COVID test happened in that district. We modeled our survey instrument on the Demographic and Health Survey core instrument, which has been done in Mali, had been done 5 times prior to our study. So we replicated the full birth history module from the DHS-7 questionnaire, but the full birth history was only in the 3 follow-up waves in 2018, 19, and 2020. So this is the DHS-7 core full birth history module in English. Don't worry about trying to read it. It's tiny. Essentially what happens is an interviewer first asks a woman to list all the children that she's ever given birth to who were living at the time of birth. There's a whole separate literature on how challenging it can be to distinguish between newborn deaths and stillbirths. The DHS has since moved to a full pregnancy history module, since we think that improves precision in estimating stillbirth rates and newborn mortality rates. But that had not been implemented at the time we did the trial. So we're collecting first the names of all children ever born to a woman, and then we go back and cycle through questions about each live birth. So what was the sex assigned at birth? Was it a singleton or multiple birth? What day was the child born on? Are they still living? How old were they at their last birthday? If they're alive, are they still living with the respondent? If they died, how old were they when they died? And when did they die? And then some questions designed to make sure that no births are omitted. So we made some minor modifications. After asking the child's date of birth, the interviewer recorded whether that information was reported via respondent recall or based on a document like a birth certificate or health card. And then we added questions about what season the child was born in, which I will talk about more in a moment. But we followed up the date of birth question with asking what season the child was born in. And then after the respondent was asked what date the child died on, asking what season they died in. So in order to do the main trial analysis, we had to do a lot of data cleaning. We created a panel data set that combined the baseline and 3 follow-up waves. We developed a set of cleaning rules based on best practices from survey methodology literature, cultural norms in the study setting, and then discussions with interviewers and field supervisors to learn more about how exactly things have been implemented in the field. We drew on information across the survey modules and survey waves to reconcile inconsistencies. So we have information from the 3 birth histories and can look across years, but we can also look at our household roster where dates of birth were included. And then in the respondent survey, we asked about how old the respondent was when she was married. Extramarital births are extraordinarily rare in this setting. So we can use date at marriage to create some bounds on the earliest possible dates of birth. Also looking at, did the respondent say that she was pregnant in the prior wave? So we can really draw across lots of different places within the survey to help narrow down potential date ranges. So we tried to narrow those as much as possible, and then eventually assigned what we called a clean date of birth and, where relevant, date of death for all children under 5. Following the demographic and health survey procedures for estimating under 5 mortality, for children that don't have necessarily a single consistent month of birth, we narrowed the range as much as possible and then imputed a date of birth within that range. And for children who died but had a missing date of death, we used what's called a hot decking procedure, where we found the nearest child that was the same sex at birth and had the same month and year of birth, and then used their date of death. So that produced essentially what we call our clean trial analytic data set. All right, so turning to our secondary analysis, that's my focus today. We're using a slightly different data set, which is what we might think of as our raw birth history panel from the household panel survey. So we're linking waves 1, 2, and 3 by the child ID. We're removing some known duplicates, but we're not going through all the cleaning procedures where we're reconciling all the dates. So this is basically preserving the dates and ages that mom reported at the time of interview in each survey wave. And I'm going to focus on a few different measures. First is an inconsistently reported date of birth. Did the respondent report the same calendar month of birth across waves? And did she report the same calendar year of birth across waves? I've mentioned these seasons that we use. So these are locally defined seasons based on the agriculture and climate. So we have, you'll notice that they're different lengths. But they're really based on things like, all right, when is peanut and maize planted? When is the maize harvested? And then we have cold season when there's not really much agricultural activity, and hot season when there's not as much agricultural activity. And to keep things confusing, I'm going to talk about a few different samples. So I will do my best to summarize which observations are in which sub-analyses today. But when we put together the full panel, we have 95,397 live births. So those are unique live births that are reported at any wave. Only 57 of those had no year or month that was ever reported. So we're just going to drop those. The first analysis we're going to look at is calendar month heaping. So looking at what month is a child reported as being born in. And to do that, we're going to look at more recent births to reduce recall bias. So we'll look at births within the preceding 5 years of any wave. But for our analyses of date consistency, we need to restrict to children who appear in 2 or 3 waves of the survey so that we have something to compare to. So here you could be in 1, 2, or 3 waves. Here you needed to be in 2 or 3 waves. So this might be due to, the child was born at the end of the trial, so they, were only around for 1. They could have appeared in year 1 and the family moved away. So sometimes it's due, or it could also be that mom moved away, so she wasn't around for a later survey. So it's not necessarily, there's lots of different reasons why kids are only in 1 wave. So we had 67,867 live births that showed up in 2 or more survey waves. And we're going to do a few more subsamples. Looking at births that occurred during the trial period, I showed you that facility delivery and healthcare utilization greatly increased. So we want to look at this subsample because there's a much higher rate of documentation for children born during the trial period. So we had 7,312 children that were born during the trial period and showed up in at least 2 of those survey waves. And then we also have a subsample for which we're going to estimate under 5 mortality rates. And I will talk more about this subsample, but these are children that were reported as being born within the preceding 5 years of the second survey wave, and that's about 18,700 live births. All right, so to estimate our mortality rates, we're estimating 5-year newborn, infant, and under 5 mortality rates. We're using the period of May 2014 to April of 2019. We use a 5-year period because that's what demographic and health surveys use. We wanted to replicate their approach as closely as possible. So they use a synthetic cohort approach. That's what we use as well. We chose April 2019 because that's the end of the year 2 fieldwork period. And children would have to be in at least 2 waves and show up in wave 1 or wave 2 to be in at least 2 of the 3 survey waves. So I'm going to not go too deep into methods, but the main thing to keep in mind here is that our mortality rates are going to be greatly influenced by who ends up in the sample of children who are contributing observation time in our Lexis diagram. So right here. All right, so to test variation, to test how cleaning procedures could shape our mortality rate estimates, we had a lot of different ways that we varied dates of birth and dates of death. And so what we did is we basically took the earliest or latest reported date of birth or date of death. For children that had consistently reported, they're sort of the same in all scenarios, but we had high rates of inconsistency. So we could also look at the oldest and youngest ages at death that were reported for children who died. Many children had an interval of dates reported for dates of birth, so we could take a random date in the earliest and latest interval for dates of birth or dates of death. And then we had some children that, due to matching these dates of birth and death, ended up with negative ages at death. So we tried 2 different procedures for handling that. One is we said, all right, everyone with a negative age at death, we're just going to assume you were a newborn. Or we took the age at death from the clean trial data set to get more variation in those ages at death. So just to illustrate 2 of those points. So this first case here, in year 1, the respondent said this child was born March 31st, 2014, but years 2 and 3, she said that the child was born May 31st. So this child would be excluded if we rely on their earliest date of birth, since our observation starts in May 2014, and then they would be included if we rely on their latest date of birth. And then in the second case, let's say in year 2, the respondent said this child was born April 19th, 2019. Year 3, let's say they reported the child was born April 10th and died April 12th. If we use April 12th as the date of death, but we take the latest date of birth and say the child was born April 19th, that gives us a date of an age at death of -7 days. So in that case, we would test either replacing the child as a newborn or taking their age of death from the final data set. And then finally, we also test the season-based measures, which I will talk about now. Okay, so as you can see, we have these seasons are different lengths. We really wanted to rely on what would be familiar and consistent across our entire group of respondents. So some of these are 1 month, the planting and harvesting season, and then we have these 3-month periods and a 2-month period in October and November. So for the single month seasons, it's pretty straightforward. If they said my child was born during peanut and maize planting season, we assume they're born during July. If they reported the 2 or 3 month season, then we randomly selected a month in that range. We collected day of birth and day of death, but we're essentially ignoring those and just doing a monthly level analysis. All right, so looking at our sample, on the left side, we have all births, and then this under 5 mortality sample is the children born within 5 years of April 2019, and then this is the children that were born during the trial, so February 2017 to January of 2020. So we see high rates of mortality among all children ever born, 17.6% later died. We see a much lower proportion among children born during the trial. As makes sense, we see among all births, so these are all ages, much higher rates of children who are living elsewhere. That's very rare among very young children. Similar birth order, but we see moms with more recent births tend to be younger, and rates of schooling are increasing among younger women. And then we see differences in births reported using a document. So more than 80% for children born during the trial versus less than 70% among all births. And then the intervention assignment is even across all of those groups. All right, so we saw very high rates of inconsistencies in birth dates across waves. So this is the proportion of children for whom their month or year of birth was reported inconsistently. So we see among all births, nearly half of them had a month or year inconsistency over time. We see reductions in those rates for younger children who were more likely to have documentation. I will note that the inconsistency rates were really similar for month and year, which I actually found a little bit surprising. So we saw similar rates of inconsistent reporting for month and inconsistent reporting of year, and much lower rates of having both month and year inconsistently reported. Unsurprisingly, we saw much higher inconsistency rates for children who later died. So on the left side, these are the rate of inconsistencies for month or year among children who are living. And then on the right side, among children who have died. So more than 90% of children who later died had an inconsistency in their reported birth date. And even among children born recently, it's still over 50%, compared to less than 20% among children who were recently born and still living. To illustrate this, we took a random subsample of 100 children who were born during the trial and had inconsistently reported dates. So the blue dot represents their reported date of birth in wave 1, the red dot is reported date of birth in wave 2, and the yellow dot is their reported date of birth in wave 3. And then on the y-axis, we have the interval between earliest and latest date in months. So we see a lot of these kids, it's really, they're off by 1 to 3 months. So it's not necessarily a huge difference. But we do see quite a few of, 12, 13 months, the children whose year was reported inconsistently. And then these at the top, we are assuming, children who have a, 15-year difference. That is not maternal measurement error or misreporting. That is some sort of survey error where there's an ID attribution issue, and that's an error on our side. All right, so turning to calendar month heaping, as a reminder, these are the children who are in the 5 most recent birth cohorts and appeared in any wave. So this includes children who only appeared once. And going from left to right, and we have calendar month along the x-axis going from left to right. The bars represent 2015, 16, 17, 18, and 19 birth cohorts. And the key things I want to highlight are we see obviously, almost 25% of children in 2015 are reported to have a December birth date. That is highly unlikely. It is because in Mali, the de facto date of birth when it's unknown is December 31st. So this represents, a high proportion of children with unknown dates of birth who, whenever they show up for immunizations or somewhere to get some sort of document, they're just assigned a December 31st birth date. And we see that that really decreased, especially once the trial was implemented. So we see a large decrease in the December birth dates showing, higher documentation. But the consequence was that we saw an uptick in February and March dates of birth in the last year. And so we think what is happening there is that this is our fieldwork period. The surveys were in the field February, March, April. And so we really spent a lot of time emphasizing to interviewers, if you're told December 31st, do more probing, ask about, how old is the child? See if you can get to a more realistic date of birth. And so we think that they were in the field, they saw the child was young and said, all right, you're 1 month, you're 2 months, and then, assign them February and March dates of birth. So that's an area for further analysis. The gray line here is the distribution of births by calendar month for the 2017 birth cohort from the Mali DHS. So we just wanted to have something to compare to what sort of seasonality might we expect. And we see that our seasonality is quite different from the national pattern. Part of that might be because there's a lot of different geographic and climatic zones in Mali. And so we expect that there is some pretty strong variation within the country. But this might also just, might reflect measurement error on the DHS. We don't really know the truth necessarily. So that's an area for further analysis. Looking at the season measures, what do we see? So this is the reported month of birth based on the season measure. So we have the seasons just labeled with our calendar months on the x-axis. The orange group are children whose mother reported a consistent season and calendar month of birth. So she said when asked what month, she said June. When asked which season, she reported the corresponding season. The green group or blue group are the discordant kids. So we had a lot of kids who were reported as having a calendar date in December, January, February. But, we actually see, well, when you ask them the season, mom might be reporting hot season or some of the planting seasons. And then we saw similar discordancy rates among children who died. So these are children in the third full birth history who were reported as later died. So it's a much smaller N than the previous slide since that was all births. And we see here that in the discordant group, we get a lot more children that when probed with season are reported to have died in July. And August is really notable because that is peak malaria season in our study setting. So we would expect to see a much higher mortality rate in these months. And that is in fact what we see when we look at the season-based measures. Obviously, this is a small sample size. All right, so turning to our mortality rate estimates, we saw a lot of differences in the newborn and infant mortality rates were driven by the assumptions we made related to date and age of death, because we're either moving kids into the newborn period or out of the newborn period, whereas the differences in under 5 mortality rate for different scenarios that I'll show you in a moment were really driven by inclusion or exclusion related to the date of birth. So are they in the sample or not? So first looking at the newborn mortality rate estimate. So all estimates are using the child's date of birth from our final analytic data set. So we're holding date of birth constant. Obviously, this is very tiny font at the bottom, but we're essentially varying what we did to estimate their age at death. And then on the y-axis, we have the number of deaths, newborn deaths per 1,000 live births. This estimate on the far left is the estimate we have using our clean final trial analytic data set. It's not a gold standard, but it should be more precise than all the other measures because it is relying on more information, and we typically had narrower ranges when we needed to impute dates. So a few things to point out. Here we have the lowest. First off, there's a very, very wide range in these estimates from 6 per 1,000 births up to 65 per 1,000 live births. That is just a really wide range for newborn mortality. And these, the really low estimates are implausibly low. These are implausibly high. Our baseline estimate was about 42 per 1,000. We would anticipate that it declined over the course of the trial. So these estimates on the left are using the oldest age at death and the latest age of death. And so they're essentially moving a lot of kids into the infant period rather than the newborn period. And then conversely, these are estimates that are replacing those negative ages at death with newborns. So they're likely inflating the number of newborns who died and pushing more children into the newborn period who died. And let's see here. So the estimate that performed best here is our random date of death in the earliest and latest interval. And that's really close to the final estimation procedure we used in the trial. So it's unsurprising that that would be close. All right, turning to the infant mortality rates, the graph is essentially the same. This is our clean trial, our estimate using the clean trial data. We see less variation here, so only 30 up to about 80 per 1,000. So it's a little bit tighter than the newborn estimates. And then here, the season-based measure actually performed the best. It was the closest to our to the estimate using the clean trial data set. And then putting the infant and newborn estimates together, I wanted to call out a few things. First is that we see a really big difference in the proportion of deaths that would be attributable to newborns across these different scenarios. So this one is replacing negative ages at death set to newborns. So we see almost all of the deaths in this version are essentially reported as occurring in the newborn period, versus here we see a much lower fraction of the infant deaths are reported as in the newborn period. So basically these cleaning assumptions are having a very strong effect on what our estimates are. And that is for cleaning assumptions related to date and age of death. All right, turning to the under 5 mortality, here we are varying the date of birth assumption. So there are fewer tweaks that we can make to that. So we have only 4 different scenarios that we ran relative to the clean date of birth based on the final trial data set. And what I want to call out here is that the rate here was 108.44 per 1,000 live births. And the rate we estimated with the season-based definition was 108.82. So they were nearly identical. And I feel like I may have skipped over this. So just to reiterate what the season-based measures mean, if a child had a discordantly reported calendar and season-based month of date, the season-based measure uses the corresponding calendar month of birth for the season that was reported. All right, so a few takeaways. So we found very high rates of inconsistencies, and that suggests there is significant measurement error in cross-sectional full birth histories. There aren't a lot of studies on this, but our findings are broadly consistent with studies from health and demographic surveillance sites, which do tend to interview women over time. And some studies from HDSS in sub-Saharan Africa found that women were making a high rate of corrections to prior survey waves, and that they found higher incompletion rates for children who later died. So both of those are consistent with our findings. We suspect that the higher documentation due to increased facility delivery and increased healthcare utilization likely contributed to the reduction in heaping that we saw in the later, most recent birth cohorts and during the trial years, but that could also be interviewer effects. So that is something we are planning to further analyze. We think that these season-based or other non-numeric response options for birth and death timing, they could be reducing the cognitive burden for respondents and recall bias in low numeracy settings, which would lead to reduced measurement error of birth date and timing of death, and thus improved precision of mortality rate estimates. This is a very, our trial was not designed to answer this question. We did not set out to do this when we wrote our survey instrument many, many years ago. So obviously, I think we need a lot more research on this, but I'm excited about it as a future direction. And I will just end with some next steps. We are planning to compare our summary birth history, so those raw counts of lifetime births and deaths, to our full birth history data, as well as looking at omissions across years to understand more about omission patterns and inconsistencies in the counts of children who have been ever born or ever died. As well as looking more at interviewer effects to understand how things like the number of waves in which an interviewer worked or interviewer gender or language affect our estimates. So I will conclude by, again, thanking my many, many, many colleagues who supported the trial over the years. I want to call out Claudia and Lena, who are research assistants here at Michigan, who have supported this analysis, and my colleagues at Musso, Lamine, and Edie, who helped a lot with the data cleaning, which made this analysis possible. So thank you.
While you're thinking of your questions, I just wanted to note that we have a free left of the books we gave out at the last brown bag. So if you were here and you wanted one and didn't get one, Paul Fleming did a book about why policies backfire and how prevention thinking can change everything in the realm of population health. So if you still want one, you can see me after the one. And we are now open for questions, open for business. So who has a question for Emily?
Hi, so I'm Zoe. I'm a postdoc here. I'm also a demographer. I study old age mortality. So measurement error has always been a very big concern. So thank you so much for sharing your work. So my question is, in the graph where you visualize the discrepancy between birth dates at each wave. So there are cases where we see, it's actually the previous graph. Mm-hmm. Yes, this one. We do see there's a variation, like some of the children have large discrepancies. So I wonder if there is, mother level characteristics or household level characteristics that sort of tell us why those folks are large discrepancies as opposed to others.
Yeah, great question. We have a full paper that this comes out of, and that is, we have some regressions where we're trying to model that, and I just didn't include it for time. We found that maternal education was really predictive, but also there's a lot of it is just age, and so much of the variation is just eaten up by children who died. So we ran some stratified regression models, so stratifying on the child vital status, and among children who are still living, some of the things that were most highly predictive were child sex, child gender, and whether the child was still living at home. So we saw that among older daughters in particular, that's where we saw the highest rates of inconsistency. And in this setting, you know, marriage can happen quite young. Young women might be living, you know, relatively young daughters are still have already, you know, gone to their marital home. They may have migrated to Bamako for work for a few years before they get married. So that if they're living elsewhere, you know, moms tended to have higher rates of inconsistencies there. And then there's also just, you know, recall. We saw really, really strong recall patterns. So the longer ago birth was, the more likely it was to be inconsistent. So there's some interesting findings, but it also is sort of driven by the things that we really expect. But I think there is a bit more we can do with looking at some of the maternal characteristics. Thank you. Yeah.
Thank you so much for this. So one of the things that I was thinking about is, I know, I think it was from the early 2000s, but Sandberg has the series of papers that are looking at like estimating infant mortality based on network responses. So, you know, asking how many births do you know of to women in your village, how many of those? And so one of the things that I think if I recall correctly, his findings were this is actually a fairly good estimator of infant mortality. But looking at your findings and considering that it looks like, you know, for the most part, especially in these high fertility, high mortality contexts, there is a lot of error for women reporting their own birth histories. And so I'm curious about how you think that might challenge some of these network-based indicators. For essentially, if women are struggling or have inconsistencies in reporting their own, these network village-based measures of mortality.
Yeah, I think that's a really great question. It has been a long time since I read those papers, but thank you for the reminder. And there are some people tested some really interesting new ways to get at mortality estimates that I did, you know, beyond census surveys, vital registration. That's an example. I know there have been some efforts to look at cell phone records. So we're trying some other new things that have worked to varying degrees. My hunch is that they would work reasonably well for under 5 mortality, but I think once you're trying to figure out was the child an infant or not, and particularly for newborn, they get really hard. And newborn, you kind of get a squeeze from both sides because it's really hard to figure out was it a newborn or, you know, say 1 or 2 month old. And was it a newborn or was it a stillbirth? You know, was it someone that should be in the denominator? Was it alive versus a stillbirth? And I think there's a lot of shame and variation in cultural practices around how stillbirths and newborn deaths are handled. And so I think, you know, also that's another reason that in some age groups, you know, if we're trying to estimate newborn mortality, that would make it even more difficult because you might be less likely to know. And older age children, you're probably more likely to know about that death in your network. But I do wonder about, you know, the data for probably 2, 3, 4-year-olds is good. Women are probably good reporters, but how good are they for newborns? Not as such a high proportion of our under 5 mortality rate now as we've made so much progress on preventable deaths. I know it's a good thought exercise. I'd love to go back to those papers and think about that. Maggie?
Thanks so much. I was wondering for the seasonal method, I know from having lived in East Africa that like the seasonality of weather is declining because of climate change and things like that. So I'm wondering if that came up for you guys, or maybe that's true in Mali, and whether there are any other ways to kind of periodicize the year besides weather.
Yeah, I would love to figure out something that's, because even within Mali, like we go 100 kilometers, you get different planting seasons. And so that's a huge problem. Like, I want to be clear, I'm not proposing this as like an alternative to DHS, sort of as a first step of like what non-numeric could work. And I had not thought about climate change. So we're in a 3-year period. I think in that 3 years, there wasn't significant variation, but I'll let Isabel challenge me on that. She is actively examining climate in this data set. So I think if we're looking at a small period, then it's less of an issue, but I think you're right that what maize planting season is now might be very different than it was 15 years ago in places that are experiencing more rapid climate change. So I think that is definitely a problem with it. And then there's also, what do you do in urban settings? They're not engaging in agriculture. So I think this could work in very limited small areas, but I think there's a lot of work to be done about thinking what are appropriate non-numeric definitions that could be used more broadly. Because if you want to even go nationally, that's not those seasons are going to change a lot.
Do you have a sense of what the maternal mortality is in this area?
Molly, nationally, I don't want to make up a number off the top of my head. It is high. We did not estimate. We had a long debate about if we were going to try and estimate pregnancy-related mortality. We put measures in the survey, but I think our data is very incomplete, and I believe there was a lot of underreporting. And so we have not tried to estimate it. There was armed conflict move into our study area between the first and second years of the survey. So there was really high displacement and high population turn, both in and out migration, people moving in from areas that were relatively more dangerous and people moving out. And so I actually included our trial flow. So we have we have a bunch of households that were lost to follow-up, and were they lost to follow-up because mom died and the family moved, or because they all left because of the conflict? We just don't know. And so we have not tried to estimate it, but I would assume it's still high since it's high nationally. Bill?
Oh, thank you. And I want to ask about loss to follow-up and stand. But I also want to endorse the effort at the seasonality thing. And I wanted to endorse that effort because it was an effort to get around the cognitive demands of the question. And traumatic experiences are cognitively impairing. That includes childbirth, let alone child death. And so I feel like finding ways to get around the cognitive demands is a cool effort. And I hear the discussion loud and clear, like seasonality might not do it, but some version of that seems really cool. And of course, as soon as you commented that the trial didn't follow migrants who moved out of the area, I immediately latched on. What does that mean for the whole thing? Like, what does that, and I understand I'm asking a different question then, what does it mean for the whole thing in terms of whether the trial worked or not? That's a legit issue, but what does it mean for the whole thing in terms of how to interpret these data?
I mean, my main takeaway is, wow, what on earth is going on in DHS? And I have tried for years to get a copy of their cleaning rules, and they have them locked down.
We know more about why now.
Yeah. The short answer is I don't know, and I'd be really curious to do this in a more stable population, and to see how much, how different do these estimates look. It would be great if we did a lot of analyses in the trial to figure out, to people who leave, how different are they from people who stayed? We have some sense that we know that the rates of loss to follow-up were similar across arms, but we don't know as much about other drivers of it that are unobservable. There is an ethnic angle to this, to the conflict. And so we know that there's higher loss to follow-up among some of the ethnic minorities who were more affected or more threatened by the conflict. And I know that they are also probably have higher rates of, higher risk of infant or under 5 mortality because they have lower access to healthcare. So
are there enough wave 1 and wave 2 that you could look at wave 1 and wave 2 who were in wave 3 versus wave 1 and wave 2 who were in wave 3?
Yeah, I think so.
Kind
That's
of
good. Yeah.
grasping for straws.
Yeah, no, I think it's a great question. I just want to highlight, this is from the DHS interviewer guide. So the DHS does give interviewers a list of events to probe around. But what you will notice, this is their example from Pakistan in, I don't know what, like 2019 say. But the events they gave them are like years apart. So someone might say, oh yes, my child was definitely born after the floods in 2010. And then you might ask, all right, were they born before or after general elections? Before. That's still a 2-year period. So, how on earth does that help us with newborn or infant mortality estimates? So there's, and you're still forcing the respondent into, to conform to our, conform to the survey rather than vice versa. Farah?
So online, Hoyt wanted to know, what about looking within family? So if an answer looks really impossible for birth A in household X, should we downweight birth B's accuracy as well? Might there be kind of a household X effect in quality of reporting?
That's a great question. Definitely when we were creating the final analytic data set, we borrowed a lot of information across births. But that is a really interesting question and idea. So thank you, Hoyt. I will take a look at that.
And I guess mine was an add-on. So when people are reviewing all the children they've ever had, in later iterations of doing the full birth history, do they ever just not mention somebody who was mentioned? So those lost births can lead to sort of like ordering and date problems. And that was part of your cleaning strategy too. And it was like you knew earlier they said there was a kid in between these two, and then later, how did you handle those kinds of?
Yeah, most of the omissions tended to be before we were concerned with births that occurred or it's children who weren't contributed to any person time. So like 2020, end of 2012, 2013 and later. And so most of the omissions, like the vast majority of the omissions were much
prior to that. Yep.
So we had some cases, but it wasn't really as much of an issue in our analytic data set. And we didn't bother trying to deal with things that happened in 1987. But we do want to go back and that's our next step, is looking at omission patterns and what do they tell us? Because we know that there are a lot of omissions. George?
So there are a lot of things about this that I'm really impressed with. I'm really, as like Bill said, I'm really impressed at how well the seasonality thing. So I had two sort of odd questions. One is, does your data show the same kind of promotion of ages of recent births that you talked about in DHS? I mean, did you design it to avoid that? Does it show up? And also I was curious about the effect of the test of these workers going out and contacting them, the two arms of that test. And if I understood correctly, that didn't make a difference on the mortality, but I wondered whether it made a difference on the reporting.
I really should have included that result in here. So surprisingly, no, because that was my first hunch. If you have a community health worker showing up regularly, you're thinking about some of these things more. And so you might be more likely to retain, because the community health workers were doing some basic education, health education promotion activities, including related to newborn and infant care. So you might be more likely to be reminded, you have a newborn, you have an infant. So we thought that would happen. And surprisingly, there was no effective intervention arm on any of these outcomes. I will say we also had really low fidelity. So only 25% of households in the intervention actually got visits every 2 weeks. A lot of them got one visit a month. What I should go back and do is look at sort of our per protocol and see among households that met the per protocol definition, did they have a difference? I may have done it already. I actually can't remember. I will check that, but I think it is a good point. And from what we know so far, no, we didn't actually see an intervention effect. Yes, we did think ahead about, can we sort of smooth out the distribution of births? So I think it does look better during the trial period, but we certainly didn't do a great job, because I think this is artificial, that February, March update is artificial. So we did something, but we didn't do it perfectly, which sort of conforms to a lot of the survey quality indicators in this trial.
But did you do better in?
We did better in the later years, yeah.
No, better than the DHS.
Oh, better than, well, we can't know because they don't go,
But-
yeah, I want to know what their raw data looks like. This is our raw data. So for a lot of those December birth dates, we did later get to something that was maybe more precise. But I would be really curious. I am confident that when they do the Molly DHS, surely they're also getting 25% of people that say my kid was born in December, or that really the bigger problem is you just get a bunch of official documents. So people, you get, this was a birth reported by document and it's still December 31st. So.
But the,
George, I'm sorry.
sorry.
Time-wise, we'll have to have you guys chat across the hall, but I'm gonna have to call it for today. Thank you, everybody who arrived. Come get a free book if you like. And this was fantastic, Emily.
Thank you so much. Thanks everyone for coming. I appreciate it.